Well, hello there, everyone. This is KP the Math G, and I do apologize for waiting for so long to give another video. I know some of you probably wait for another video from me, and I apologize for that. But been busy out in the yard trying to get some things ready, both between cutting the grass and weed eating and getting the greenhouses ready for plants to grow. And we do have some couple of gardens that were small gardens, but we still have a couple that we're working on. So I've been busy a little bit. So anyway, 2007 free response question number 6. We're given that alpha at x is equal to k times square root of x minus ln of x for x greater than 0, positive, simply because, not because of the square root of x, but because of ln of x. X can be 0 here, but x cannot be 0 here. You have to have x being greater than 0 because of the ln of x here. K is a constant here, and so the first part of question A is find f prime and f double prime at x. So that's two parts, so we're going to look at both of them. So let's see if this blue will write good. F prime at x. Okay. Let's first of all write it as f at x, as I like to write it in terms of exponents. That's the square root of x, x to the 1/2, minus ln of x. Okay, now f prime at x is equal to, let's see. All right, so let's see. We bring this in front, don't we? So 1/2 k x. Now remember, we take away 1, so 1/2 minus 1 is the same as 1/2 minus 2/2. But that's going to give us x to the negative 1/2. That's taken care of. K, remember, is a constant, so we don't have to worry about the product rule on that. No, because K is just like a number. So we just go with x here and differentiate that one. ln of x is 1 over x. And if you get it down to that, that is good enough. Before we go into the second derivative, I'm going to rewrite 1 over x. Alright, 1 over x to the 1 is actually x to the negative 1 over 1. So I'm going to rewrite that for the time being. And you can leave this if you're doing the AP exam, AB part, or BC for that matter. You can leave the negative exponent. Okay, negative exponent minus x to the negative 1, and that's the reason I did that, is so that I can do the second one a little easier. It's just easier to follow like that. Okay, so there's the first one. Let me get something that writes. I think this is a little streaky here. It kind of does okay and kind of doesn't. So I don't like kind of. I want it to work. So let's get the green out and let's do f double prime with that one. Okay. All right. So we're going to take this one here. We're going to multiply again. Push that out in front. So negative 1/2 times 1/2 k x. Now remember, we're taking 1 away, so minus 1. So minus 1/2. So x to the negative 1/2 minus 2/2 is x, well, is negative 3/2. So x to the negative 3/2. Alright, so negative 3 over 2. 3 over 2 here. Alright, like that. And then, okay, so let's see, we're going to make this this other part, the negative times the negative is a positive x. Now minus 1 from that one. Minus 1 is negative 2 right there. And let's see, let's kind of multiply this out. So this is equal to negative 1/4 kx to the negative 3/2 plus x to the negative 2. And again, you can leave that in the negative exponent form. If you're in just regular calculus, you may not leave it in that form. I'm not sure. That depends on your instructor or professor. And let me go up here. I have moved my board over to the left a little bit. Let me make sure everything's lined up on the camera. Alright, there it is. Okay, got it. Okay. Alright, there it is. That's the A part. So you had to find F prime and F double prime. And by the looks of it, that's what I have on both of those. Okay. Yeah, okay. Alright, there is that one for sure. Okay. And I have the answer right there. For whatever reason, they did bring this down on the first one here and made it x to the they wrote it as x to the 1/2 in the denominator, like that. So either way, it's fine. Good. You can just leave it like this. All right, that takes care of the first one. The second one, let's look at the second one here. Kind of like this one here. I'm going to go ahead and I'm going to leave this up here because we need those derivatives to answer the other two questions. Okay. Alright, I don't know if we'll get into C part, but I would like to get into B, and I may just have to flip this over, just turn it over and work it out. So the B part says, for what value of the constant K does F, what value, alright, what value of K does F, so we got to find K, a value for K, does F have a critical point? Alright, so have a critical point, I'm just going to abbreviate that, critical point at x equals 1. Alright, and then the second part of this question is, it says, let's see, for this value K, determine whether X, alright, so determine whether F is a relative max or a relative min or neither. And it is, I know I'm abbreviating, it says for this value of K that we find, determine whether F is a relative max or relative min or neither. Justify your answer. Okay, let's deal with the first part of this. For what value of K does F have a critical point at x equals 1? Okay, now critical points. If you have a function here, F, how do you find a critical point? Yeah, you got to use the second derivative to find a critical point, and you know that you got to set this equal to 0 to find the critical points, right? And we're looking for the value of K. I'm going to use this down here. Alright, so let's see. Mike can be able to do this. Let's get another color so everything won't blend in so well here. Alright, so let's see, we're saying then that 1/2, well, let's see, I'm looking at the first derivative. Alright, kx to the negative 1/2 minus x to the negative 1. Now, that is f prime at x, okay? And we want to set that equal to 0, okay? Let me kind of look at my notes here and kind of see where I'm at here. Okay, so let's do, first of all, let's instead of setting it equal to 0, let's find f prime at 1, and then we'll set it equal to 0, okay? This should be fairly simple. F prime at 1 is 1 times k times 1 to the negative 1/2 minus 1 to the negative 1, okay? Alright, like that. Now, anything, 1 to any power, okay, to any exponent, whether it is positive or negative, is still 1, right? Okay? So, anyway, this is still 1. So what we have here is 1/2 k minus 1. Alright, 1/2 k minus 1. Alright, that's where we are at this point. Alright, now let's take that, let's flip the board over. I will flip it over. 1k minus 1. Alright, so we're talking about a critical point. Okay, and we got 1/2 k. Alright, my wife just walked in the door, y'all. K minus 1. Okay, 1/2 k minus 1 is equal to 0. This is when we have f prime at negative 1. That's f prime at negative 1 right there. And we're setting it now equal to 0. Okay, that's what we're looking at this point. Easy to solve, isn't it? So plus 1 on both sides. 1/2 k is equal to 1. And when I multiply by 2, well, we have k is equal to 2. Alright, now the second part of that has to do with this. It says now determine if f has a relative min or a relative max or neither at x equals 1. Justify your answer. Okay, so here's what we need to think about. Relative max. Alright, relative min. And let's just not worry about neither for right now. Okay, one thing about it, we still have to deal with the first derivative. We know that the first derivative at 1 does equal 0 when k is equal to 2. Alright, and then now let's see, let's go back to the other side. I want us to look at the first and second derivative. Okay, so we had f prime at x and we had f double prime at x. Now, why am I interested in f double prime all of a sudden? Well, here's what I'm thinking about. When I'm thinking about f double prime, I know that f double prime deals with concavity, right? Concavity. So concave up, which means that we have a min. Concave up, we have a min, right? If it's concave down, we have this right here. Concave down, isn't it? That's concave down. Concave up, concave down, we have a max. So that's what I'm going to use to determine, that's how I'm going to justify my answer, is looking at that scenario there if I know what the second derivative holds, if this second derivative, by the way, we need to remember now, if f double prime is greater than 0, we're at concave up, and if f double prime is less than 0, we're at concave down. Okay, and that's what we need to look at: concave up, concave down. And that's why I want to, again, this is a min here and a max is here. Alright, now if this does not exist, then we say neither, right? Okay, so that's where we're at this point. So let me address the second derivative. Okay, that's what I want to do at this point. Bear with me just a little bit. Alright, so I wrote some notes down, so bear with me while I'm looking at my notes here. Alright, I'm going to erase this so I can have a little room to work here. Alright, I'm going to look at f. Probably I just need to look at f double prime at x now at this point. Okay, f double prime, and it was, and I could easily flip the board over, but it's negative 1/4 k x to the negative 3/2. Let's see, plus x to the negative 2. Let me double check. I think I did write everything. I didn't miss a sign, did I? Yeah, there we go, right there. Negative 1/4 kx to the negative 3/2 plus x to the negative 2. Okay, that's what I want there. Oh my, my board is having trouble flipping over. Or maybe I'm having trouble flipping it over. Alright, there it is there. That's what I'm going to check for now. So at k being 2 and x being 1, let's try f double prime at 1 now. Alright, at 1. Let's see what happens. And when k is equal to 2, and that's when we got k being 2 just now, didn't we? We just determined that on the first derivative there, that k is 2. Alright, so negative 1/4 times 2. Alright, times x, which is 1 to the negative 3/2, plus 1 to the negative 2. Now remember, 1 to any exponent is just 1. Alright, even 1 to the 0 is 1. Okay. Now let's see what we have here. Let's see what this is. This is negative 2/4 right here times 1, so that's equal to negative 2/4 plus, and then this is just 1. 1/1. This is actually 1 to the negative 2 is 1/1 squared, which is 1/1, which is still 1, isn't it? Okay, alright. And that's kind of the way I'm showing you this. 2/4 is 1/2, so negative 1/2. Alright, negative 1/2 plus 1 is 1/2. 1/2 is greater than 0. So, therefore, let's go up here. Now, therefore, we have f is concave up at x equals 1. Of course, we know that k is equal to 2, right? Alright, and therefore we have a relative min at x equals 1. Voila, there it is. Alright, so that is what we have. And actually, they say by the second derivative test, this is the second derivative test. We found that 1/2 is greater than 0, and that's a good quick way of doing it, isn't it? Okay, is just look at that second derivative. Think about that sometimes when you're trying to say, okay, is this max, is this a min, or neither? Do that second derivative, and you can see this is greater than 0. That means we do have a min. It is concave up, so we have a relative min. Do not say a max if it's concave up. Remember, concave up is this way. We know that, don't we? So that means then that we have a relative min at x equals 1. I don't know what the y value is. I just know at x equals 1, I have a min there. Okay? Alright, there it is. Let's see it another time, because this is one thing. My wife is waiting for us to eat lunch. I'm going to take my wife out and we're going to have lunch today. It's Sunday. And anyway, we will we'll need more time to do part C anyway. It's going to take a little work. So we'll work on that another time. KP the Math G, just about ready to sign off. Please make sure that you hit that subscribe button. Okay, if you will. If you don't, it's okay. I just hope that I taught you something here. Okay, but it would be nice if you did. Hit that subscribe button and the like button as well. And if you'd like to make a comment, please make a comment. And I do appreciate any and all comments. I appreciate you. I don't take you for granted. I really don't. And I do these lessons for you. And I love calculus. I love doing this. It keeps my mind sharp, and I like to keep my mind sharp at my age. I'm only 63 years old. I'm still young. At least I think so. Alright, KP the Math G signing off. Have a great, great day.